Good afternoon and welcome to our 19th annual exhibit of hydrogen fuel cell technologies. We've been here since 1995 discussing the innovations, and they are numerous this year. We have a specialist to invite up on the stage, someone who's going to be able to tell us about wind hydrogen, the opportunities and the challenges that poses. And that specialist is from NOW, the National Organization for Wasserstoff and Brennstoffzellen, which is, of course, hydrogen and fuel cells. And he is Dr. Oliver Ehret, who is head of the program of hydrogen provision. Please welcome with me Oliver Ehret.
Hi.
Hello. So let's have a seat.
Yeah.
So Dr. Well, may I call you Oliver?
Or you can, very welcome.
Let's start with wind hydrogen. People talk about hydrogen as an energy carrier. There's something that people think of as dirty hydrogen. It's created through fossil fuels. Your focus is really wind hydrogen, which is this absolute tree huggers, it's beautiful, green source of energy. What are the challenges and the opportunities posed by wind hydrogen?
Well, I suppose, first of all, it's a reality. We're in a situation now where we got a lot of renewable energies. And I think there's good news for the planet. There's also good news for the economy in the long run, at the very least, and I believe in many regards in the shorter run. Now we need to integrate this energy into the energy systems. So hydrogen is just an energy carrier. I can produce it from various energy sources, including renewable energy sources. And now I can use this hydrogen for various applications, like transport applications, stationary applications, as a storage, as a way to get into renewable energies into the transport sector and the stationary sector.
And you mentioned a number of sectors there. When we break those down, where do you see the first applications coming? We have already hydrogen, the potential of producing hydrogen with wind power. What do you think are the first applications that come to mind? Is it going to be vehicles? Is it going to be the home user and stationary applications? Where's your perspective on that?
Well, quite a few of them at the same time. The good thing is I believe these things develop in parallel. I mean, we got a lot of user technologies. We got, for instance, developments such as the Clean Energy Partnership in Germany and H2 Mobility. Also development in other countries like California Fuel Cell Partnership, Japanese developments. All these people need hydrogen. Now you got the opportunity in Germany to use this hydrogen. So this certainly is a market that's going to be emerging. At the same time, I see all these actors in the stationary sector, they're just craving for a solution to energy storage problems. One of the hottest topics, you do need energy storage. So this is what they need it for. It's not tomorrow that you make a lot of profits or whatever, but it's something you need to invest in. You need to explore these opportunities to see how it's going on in the future.
This is a very burning issue here. Energy storage, why is it so important? The potential to develop gigawatts of wind energy in the north of Germany is already there, but we are already dumping energy, wasting energy, because the grid is not absorbing exactly the amounts we're producing. The supply of wind energy can do whatever it wants to do, but the demand of electrical energy is not parallel to that. So in order to recoup that energy, to save that energy and use it, you have to do something with it other than just pumping it into the electrical grid. That all begins with electrolysis. Where are the issues there? Are we happy with the PEM electrolysis? What sort of developments can we expect on the field of creating hydrogen through electricity?
Well, electrolysis is an old technology. It's been with us for decades, literally. But in the past, it wasn't really that competitive, because when you needed hydrogen, you could produce it from other fossil sources. This was just cheaper. But now it seems a market is developing for electrolysis, both for alkaline technologies. This is like alkaline electrolysis. This is the established kind of workhorse in terms of electrolysis, and for PEM technology, the newcomer there. I think there's a bit more to do in terms of development with PEM electrolysis. At the same time, it holds for the future especially large opportunities for further development. For instance, what we need is larger units, kind of megawatt electrolyzers. We need to come down with costs. Lifetime is an issue to be looked at. Mass production, because at this stage is in smallish companies, and because you don't have a mass market, you have to develop these production methodologies to go to the market there.
Are there any particular advantages or disadvantages? Often when I think about topics, I look for a single solution, but there may be an argument for using sometimes PEM cells to recover and store the electrical energy through electrolysis, and at other times an alkaline system. Are there specific examples where you could say it's better to use an alkaline electrolysis process here and a PEM electrolysis process there? Are there distinctions?
Well, I would say it depends on the application. For instance, where space is crucial, the advantages for PEM electrolysis technology simply because it needs space. Another example or advantage is also it's more responsive in a way. This is not to say that alkaline electrolysis is not responsive, but it's not quite as responsive, like two changes in fluctuating of energies as PEM electrolysis. So these are things to consider. However, an advantage, for instance, of alkaline technology is it's more reliable at this stage because it's a longer established technology. We believe there's promise with both of these technologies, and both of them do require and kind of earn further development efforts.
As soon as we face the issue of what to do with the, some people call it excess energy, I like to refer to it as simply wasted resources. When you have wind towers up and they're producing electrical energy that is not being used on the grid, it's either wasted or you use electrolysis and create hydrogen. But the next question, of course, is you're creating hydrogen so that you can store the energy. Now you have to store the hydrogen. Where?
Well, different opportunities. The first very suitable storage is simply a vehicle tank, because this is where we can put hydrogen. This is one alternative. When it comes to larger scale like storage, caverns, that is a possibility. For instance, we got a study looking into caverns, hydrogen caverns, and this study says it's quite a useful opportunities. There are also various companies, and we're talking about large companies with an established reputation. They know how to handle hydrogen gases like this. They are interested in caverns. You can also look at the issue of injection of hydrogen into the natural gas grid, because the natural gas grid can absorb quite a bit of hydrogen. Today, depending on the figures, 5–10%, presumably even more in the future, if you make sure that the grid can deal with it. So all these are storage options. We use the same hydrogen produced from renewable energies in this case and store it wherever appropriate for the particular market.
So to get back to this caverns, basically we're talking about large holes in the ground. Like, are these naturally existing caves? Are they mines that are no longer operated? Are they just like a natural resource? There's a hole there and you pipe it in, or do they have to be made?
Well, we need nature because we need salt-like domes, salt structures. They're pretty thick structures, a couple of miles, sometimes kind of deep. And what you do there, you produce a hollow in the salt. An advantage of caverns is they're quite cheap like to produce. You get a lot of storage, you get big storage volume, and what you do, you inject some water basically to soil out, well, to take out the salt kind of, and you get rid of this kind of mixture between water and diluted salt in there, and you put it somewhere. So you do have to you do have to create them in a way to build them, but you also need like these salt formations in the first place. The advantage in Germany is there are not very many locations where you find these salt formations. In Europe, that is mainly Germany, Poland. We got some formations in the US and some like in the UK, but not there too many. For Germany, the advantage is you've got a lot of like renewable energies. You got all this issue of fluctuation. You got hydrogen. Hydrogen requires a storage. You got at the same time like vehicles. So all these factors come together, and this is a big advantages that we have here.
Germany seems to be on the forefront also of in the field of R&D. And in the field of studies. You've looked very closely at now with studies on the applications of electrolysis. So there was a study in 2011 and another study in 2013. If you could summarize These are, of course, studies that the government addressed you to do, basically. They want to know what to do with this excess energy, and in future what to do with the even larger quantities of energy produced through wind and other renewables, solar. So what are the results of the studies in 2011 and 2013? If you could break that down, what are the big messages you sent back to the government?
The study of 2011, it looked on the kind of the state of the art and the future development potential of electrolyzers. We knew there was a lot of technology out, quite a few actors, but it was important to really to establish for all of them where we stand and what to do really in the future. So in the 1011 study, we looked at into these big alternatives that are there, mainly PEM and alkaline electrolysis. We found out that in both areas we do have to do something to get along, so progress won't come on its own, but if you do it, you will have it. For instance, one of the issues to be addressed is like longer lifetime, cost reductions, again, kind of improved efficiency, these things. So in other words, we do need demonstration projects, we do need further R&D and electrolysis development. Important was also the recognition, because in the past there was no market for electrolysis, or not a very large market, that is now massively growing due to various new applications, that the chances to realize these technical potentials are quite good. Another study we had was about the integration of wind hydrogen into the wider energy sector. What we did there, we looked exactly, it was just like, introduced to the public this January. We just looked at the exact wind amounts of what people call excess wind, what we want to use like in German areas, coastal areas. We found at least 2030 there's quite a substantial amount of wind hydrogen. We then figured out a way kind of to store this, to convert it into hydrogen, and then to store this hydrogen in underground salt caverns. Here the conclusion was, this is a technologically feasible way. You have to do something about it, but it is really possible to do this. We also looked what to do with the hydrogen. We looked at the possibility of using it as a fuel for vehicles. We found this to be economically viable in quite a few cases, 2030. And we also looked at like re-electrifying it to stabilize the grid. Also, this is an opportunity to do. And we did find that 2030, in some scenarios, we can be competitive against like hydrogen produced from fossil fuels, natural gas.
I should mention that if there are questions from the audience, there is a microphone available, so just raise your hand. Many of these issues require not only study but demonstration. People like to see something working on the ground, walk over and give it a kick and see if it's sturdy. You're also involved in demonstration projects. Could you talk about what exactly is up and running on the ground right now? What sort of demonstrations you have on the go?
Yeah, very generally speaking, the NIP, that is the German National Innovation Program, Hydrogen and Fuel Cell Technologies, that offers this very large budget for demonstration and R&D projects. This is 1.4 billion euro over 10 years. So we've got very many demonstration projects and also R&D projects running. We've got quite a few projects regarding wind hydrogen in the realm of the transport, because in the clean energy partnership, this is our big lighthouse project for transport applications. We got quite a few electrolyzers. We have 50% of the hydrogen to be produced from renewable sources 2015. So this is one thing. We've got another project that is called Renewable Hydrogen, Werder Casino Alten Treptow. This is the name of the place where it is. This is a 1 megawatt PEM electrolysis, not PEM alkaline in this case, and they're looking how to use excess wind, convert it into hydrogen, store it, and use it then at times of demand when there's calm and you still need electricity for your wind generators, lighting, and so. There's also, for instance, Ehret, they've got a hybrid power plant. Is not only partly funded by the NIP, a small part of it really. And only yesterday, we introduced to the public a new project. It's about the injection of hydrogen into the natural gas grid. It was in Hamburg. It's going to be a 1 megawatt PEM electrolysis, and you produce hydrogen from electricity. and you just inject it into the grid. A number of companies involved there, and we're looking with great interest in this new technology.
Now, here is where I like to get technical, because there are some issues that are really interesting. The fundamentals are clear. We have a source of wind energy. The grid cannot absorb all of that production, but it would be useful if you could use it when peak demand is happening. And slowly we can phase out other dirtier forms of electrical energy, for instance, coal production, even perhaps natural gas, which bridges those peaks and makes life sustainable here. The grid's very reliable. We rely on it. In Germany, it is phenomenally reliable, but its future is changing. And here we have this issue of the gigawatts of power that are being created through wind energy. So here's the question. One concept that I've heard from you is where we generate hydrogen, we store it, and potentially we can convert it back into electrical energy. Potentially we could use hydrogen directly in mobile applications and also in the home. We would need a grid for that. Or we could inject that, as you mentioned, into the grid, and there we're talking about the existing natural gas grid, which has very limited tolerance. The natural gas grid, I've learned, is not capable of dealing with 100% hydrogen. It's just not built for that gas. It's corrosive, it wouldn't work. So there's tolerances of 5, 10%, maybe more. That would be another option. And the third option, I suppose, outside of building a 100% hydrogen grid for the whole country, which is an investment, would be to do what you mentioned briefly, and that is add CO, add carbon to the hydrogen, make it into something like natural gas. I believe you refer to this as the methanization. It sounds like it's making methane. It's basically turning hydrogen back into something like a fossil fuel by adding carbon, because it's easier transported, its energy density is better, and there are other applications. What do you think is the most viable route to take when we are faced with gigawatts of power in the future? What do you think will happen?
Well, I think what you can do, it takes quite a long time to reach these limits in most parts of the gas grid, because there are not that many electrolyzers. There's going to be a high demand for transport, hydrogen in the transport sector. So these are markets that need to be satisfied first. So it's going to reach some time kind of until you reach any of these thresholds there. Then I also believe if you find out about problem areas in the natural gas grid, it is possible by replacing gradually certain components that might provide or raise issues for concern really, that you then achieve quite a cost-effective solution to get the natural gas grid ready for higher percentages of hydrogen. We also see that there's a high efficiency, like using hydrogen directly. If I use it in a fuel cell, I can this hydrogen that is not cheap to produce, but it has many advantages. I can use it directly with high efficiency in a fuel cell. So I believe this is the more straightforward look. And it's good for the gas industry to make sure that gas has the right quality. It is good to that issues are explored in terms of R&D, that you make sure that if you have certain gas pipelines with smaller diameter where you don't have so much hydrogen or gas as a whole, that hydrogen doesn't exceed certain thresholds. So these are all worthwhile things, but I believe using hydrogen either for vehicles or to inject it into the grid, or also as an industrial gas, that's another opportunity that hasn't been kind of mentioned. That is the more advantageous way.
This, of course, is an incredibly important topic right now in Europe, so it's a conversation we'll have to continue. We invite you to do this. Dr. Oliver Ehret, his booth is B56, and it's in this direction. And you can join Dr. Ehret there immediately after this interview, I believe.
Yeah, sure.
Dr. Oliver Ehret, Oliver, it's been a pleasure talking to you. Thank you very much.
Thank you.